Hello everyone, welcome to Engineering Archives. Let's look at our learning problem number 2 for the chapter Cartesian vectors. So the problem asks us to write this vector as a Cartesian vector. Okay, so before we begin, let us first see how a Cartesian vector looks like. So a Cartesian vector looks like something like this. Fx I plus Fyj plus Fzk. So Fx is the component along the x-axis, Fy is the magnitude of the component along the y-axis, while Fz is the component along the z-axis. So basically, to write this vector as a Cartesian vector, we need its components along the x, the y, and the z-axis. Alright, so let's do that. To find the component along the, let's first find the component along the z-axis, since we can simply find that just by looking at the diagram. So Fz. So from the diagram we can see that this angle should be 90 degrees since this is a right angle, right? And this vector makes a angle of 45 with this plane, right? Which means that this angle should also be 45, so that these two angles should add up to give us 90 degrees for this angle. So that tells us that this vector f makes an angle of 45 degrees with the z-axis. Since this angle here, right here, is 90 degrees, so we can simply say Fz, or the component of the force 50 pounds along the z-axis, should be equal to 50 pounds cos 45, right? And this would give us 50 cos of 45 gives us 35.4 pounds. Alright, so let's move on to the component along the x-axis. So to find this component, we are going to employ the use of trigonometric identities multiple times. So we are going to follow the same procedure as we did in the previous questions to find the components. So let's write down the magnitude of the vector first, 50. Now we need its component along the positive x-axis, or the x-axis. And we can see that the x-axis line is right here. So first of all, we can do 50 cos of 45 to get the component of this vector along this line. Why are we finding this vector? Since we don't have the direct angle between the vector and the x-axis, so we are forced to first find its component along this line. Since we have the angle between the component and this line, which is 45 degrees, we can find this component. And once we have the value for this component, we can use this right angle triangle right here to find the component along the x-axis. Okay, right. So by saying 50 cos of 45 degrees, we get the magnitude of the vector along this line, right? But now since we have this line, we need to find the component along the x-axis. So to do that, we need either this angle or this angle, right? But we can get this angle since they have given us this small right angle triangle, and we can use this small right angle triangle to find this angle, right? Let me clean this up because I think it's a little bit untidy here. Okay, so as you can see, they have given us this small triangle right here to get this angle, right? So we can find this angle by simply doing tan of alpha is 3 by 4, or alpha is equals to 36.87, right? So we get this angle this angle is equal to 36.87, right? So now since we have the component along this line, we need to find the component along this line, right? And since we also have this angle 36.87, we can simply do multiplied by sine of 36.87, right? So by doing sine of 36.87, we get this component along the x-axis. But also notice the direction is towards the negative x-axis, so we need to add a negative sign before the whole thing, right? Okay, so the value that we get for this component is equal to negative 21.21. Alright, let's move on to the component along the y-axis. To get the component along the y-axis, we follow pretty much the same procedure. First we have to find the component along this line, and the component along that line would be equal to 50 cos of 45. And after that, we need the component along this line, right? Last time we found that line. This time we need to find the component along the positive y-axis. And to find that, we do cos of 36.87 instead of doing sine of 36.87. Right? And also notice that since it's in the positive y direction, there is no need for a negative sign, and the answer that we get is 28.28. Right? Now that we have all our components, we can write the Cartesian notation by in the following way. So first off, f of x is negative, so we say negative 21.21 I, right, plus fy, which is 28.28 j, plus z is also positive, so 35.41 k, and this is the Cartesian notation for this vector. Thank you very much. See you in the next video.